Hello. We would like to show you our project where we use linked data to help the AEC industry. We specifically want to help the industry by streamlining nitrogen regulation compliance. Due to nitrogen regulation, the AEC industry has faced many delays. In order to start projects, project plans need to be approved for their expected nitrogen emission. In the Netherlands, this can be done with the Areas calculator. This allows people to input their project data and calculate their estimated emissions. This can be a long and tedious process for larger projects, which is why we want to automatically integrate this calculator with project data to streamline the process. We propose that with linked data, we can connect the areas calculator so that it automatically fills out all needed data for the calculator and generates a report. Nitrogen emission has been a topic of discussion in the Netherlands for quite some time. We are exceeding the boundary for nitrogen emission, and the governments are introducing regulations to try and reduce these emissions. The AEC industry is heavily affected by these regulations, causing time investment into adhering to these regulations. For this project, we want to make a more efficient system for construction projects, which makes it easier to comply with environmental regulations. We aim to create a user interface which automatically grabs data from linked data and allows the user to input, edit, and upload directly through the website. For this project, we were tasked to use building data in linked data. The standard for building data is the NEN 2660 ontology. In order to automatically input data into the areas calculator, we need to know the input requirements and build a standard ontology around that. This allows us to connect the areas calculator to the building data in the NEN standard. To ensure that the project data that the user can upload is correct, we need to validate the file. This can be done through Shackle. Shackle allows us to design shapes, which is a set of conditions that a dataset must meet. With this, we can create constraints for project files so that they are compatible with the areas calculator. For this project, we built a prototype user interface. The user interface consists of two parts. The first part allows the user to upload project files and validate them to ensure areas compatibility. The system will give an error when one or more constraints aren't met. When the constraints aren't met, the user can fill them out manually and store them back in the file. Then the file can be revalidated to ensure compatibility. The second part consists of the areas calculator. The user interface uses the areas API to send the data from project files to the areas calculation for calculations. After the calculations are done, a report can be downloaded to view the expected emissions. With this project, we've helped simplify compliance with nitrogen regulations and contributed to improve efficiency in the AEC industry. This was our overview of our project. Thank you for listening.